Good day, ladies and gentlemen. This is now video 3 in our series on the exponential laws, specifically looking at the second law. Remember that the second law is all about division. So this is Mr. VG, and I hope that you're enjoying these videos and you are gaining some new insights into this beautiful, beautiful world of mathematics. So what happens if I've got 5 to the power of 3 divided by 5 to the 2? I think you know what I'm going to say. If you don't, I am going to say, go back to the definition. What is the definition of 5 to the 3? Well, that's 5 times 5 times 5. And if I divide it by 5 to the 2, which is 5 times 5, I can divide top and bottom by 5s. Once, twice. So I'm first of all dividing the first set of 5s away, leaving me with a 1 and a 1. And then I've got the second set of 5s, and that leaves me with 5 times 1 times 1 over 1 times 1. Now, if you remember from the first video, if I'm just left with a 5, I can write it as 5 to the 1. So therefore, 5 to the 3 divided by 5 to the 2 is equal to 5 to the 1. Now the question is your spider sense tingling, yes or no? Do you see something happening? Let's investigate another one. What if I've got 4 to the power of 5 divided by 4 raised to the power of 3? Well, let's go to the definition. At the top, I have 5 4s, and at the bottom, I've got 3 4s that I'm multiplying. Which 4s am I going to divide away? Let's start at the back. That 4 and that 4. The other 2 4s, and then last the middle 4s. Which means I'm only going to be left with 4 times 4, which is 4 to the power of 2. Now my question that I'm asking you is, are you seeing some kind of pattern? Is there a spidey sense tingling in you? Well, my spidey sense is looking at the 5, the 3, and the 2, and I'm seeing that 5 minus 3 gives me 2. Now the question is, does it always work this way? Well, let's have a look if I bring in variables. Now, I know you guys don't necessarily like bringing in x's and y's and things, but it's always useful because I could then replace x with any number. I'm generalizing my law at the moment. So I'm kind of going from something that I am used to and venturing it into the unknown. Now I sound like Frozen 2. X to the power of 7 minus 4. That's what my spidey sense is telling me. That I'm taking that 7, I'm subtracting the 4 from it, and that becomes my new exponent. Let's again start with the definitions. X raised to the power of 7 is 7 x's that I'm multiplying. The same then goes with a 4. X raised to the 4. I'm multiplying them, and now those x's divide away. What am I left with? Oh my goodness, x to the power of 3. So does it work? Yes, it does. Yes, it does. Now here comes an interesting thing. What if I give you 6 raised to the power of 3 divided by 5 raised to the power of 3? Let's start with the definitions. Unfortunately, nothing divides away. You guys see the issue we've got? Usually we could have gone divide the numerator by the same thing as the denominator, and things just in the words that I really don't like to use, but you guys understand it, cancel out. Nothing divides away or cancels out. So therefore, my answer is 216 over 125. There's no shorter way. There's no shortcut. My spidey sense has failed me. So what does law 2 actually say? Law 2 says, if I have two powers, x to the power of a divided by x to the power of b, it says, I can simply subtract the second exponent from the first exponent. So in other words, it becomes x to the power of a minus b. So very important. If I divide the same basis, then I subtract the exponent. There's the shortcut. There's the law. But there must be a divide, and there must also be the same basis. It cannot be different basis, because then things don't divide away anymore. I hope you enjoyed this video and are ready for the next video, where we are going to look at practicing law 1 and 2. So stick with me. I know it's not always easy, guys. I know it. But it's so worth it if you push through, if you put your head down and say, I'm going to practice this until I get it, then you are going to achieve success in life. This is Mr. VG signing out. Cheers.